So this is our last, speech now, and it is our pleasure to welcome our keynote speaker, community leader and CNCF Ambassador Alessandro has spent the last few years building cloud-native infrastructures for Microsoft customers, animating the Dutch community and training others to pass the CKX exams. He has passion for all things cloud-native. He's been around open source for 25 years and recently moved to a new developer relations role.
His talk is about the way of cloud-native AI, and during this we will delve into the magic world of LLM training and inference using cloud-native and open-source tooling. We will explore how the current Gen AI revolution benefits from open standards, programmable infrastructure, and the powerful paradigms of cloud-native. We will also explore practical knowledge on how and why running AI and ML workloads on Kubernetes, and end up with a short demo. Let's welcome on stage Alessandro Vozza.
Thank you. Welcome.
Nice. That's all the Greek I know. Thanks to my wife, which is Greek, and she taught me these two words, and I'm learning, right? So that's the next thing I'm gonna learn after all this stuff. So thank you for having me. I'll be brief, and I'm just between you and the party, so I'll take it from here. And I'm really, really happy to be here. So it's my first Greek conference, and it's so nice to escape the cold of Amsterdam for coming here. And I hope there will be more. So we're going to talk about cloud native. Who knows Kubernetes in the room? Yeah. Well, it's a rhetorical question. Everybody knows Kubernetes, at least what I assume. I started 8 years ago to talk about Kubernetes. The question was, do you know Kubernetes? And today is, how do you use Kubernetes? I assume everybody does. So I like to start with just an interesting fact. You know what this is? This was taken a few days ago. It's the first detailed image of a star. 160,000 light years away is the WOW G64 star, and it's amazing. I just like to start with something that gives you perspective, right? So we talk about AI, cloud native, but there's a whole universe out there, and something that I really like to show. So I'm from there, right? So if you wonder about my accent, I'm Italian, I'm from the south, what used to be called Magna Grecia, so I think we are una faccia, una razza, right? So we are taken from the same tree, me and you guys, you people. So that's my beautiful wife, we live in Amsterdam. I run the Dutch Kubernetes meetup for 8 years, so I've been doing communities for a long time. I still like it. I'm not giving up. Actually, there is a meetup tonight in Athens. I'm also going to go there and meet other people from the community. Shout out to Christos, another CNCF ambassador. So the CNCF is the Cloud Native Computing Foundation. We're going to talk about it. Nominates every year ambassadors, right? So people that have some roles in the community. And I'm one of them. I'm very proud of. And Christos is one of the Greek ambassadors. And he's here around. I don't know if he's still around. I did work at some big companies before. Now I have a little startup called kubespace.io. I'll be happy to explain to you what it is. And I'm recently been elected technical lead for the Technical Advisory Group, TAG, Environmental Sustainability. It's also a topic that I'm very passionate about. I'm going to also introduce it in this talk about sustainability of AI, right? So so something personal. How did I get there? I got here. What brought me here? This was my first computer, if you know what it is. This was my second computer. This is Amiga OS. This was one of the first time 25 years ago, I installed Linux for the first time, never looked back. Always open source in my life. Slackware 0.9, if you are that old to remember. I used this as well, Windows. And then we move into, so I'm from there, right? So we used to have computers at the university, right? So that was my thing. Also, maybe that's why I studied chemistry, because there was a campus. I could go there, use computers. And there was the only internet connection was there, right? So it was a time where computing wasn't ubiquitous like it is today. And today, everybody has a phone in your pocket, and the same phone it has the even more computing capacity than the computer that sends the man to the moon. So I witnessed this change, right? So this shift from people in the lab code programming computers to hackers and geeks in the basement trying to figure it out how to crack into banks and credit card numbers, into everybody as a powerful computing device in a personal computing device. This is really the personal revolution. So everybody has this, and then now we have this massive distributed computing. This is an Azure data center. Like there are so many out there. You can tell this from the Netherlands, who knows why? You see the windmills in the back? This is from the Azure region in the Netherlands. So now we deal with massively distributed computation systems, right? So, and that's not what we were prepared for, I think, and this is also something that kind of triggered the digital revolution that we are witnessing now. And I'm lucky enough, I'm alive, and I witnessed another revolution in computing, which is not AI per se. AI being around for a while, is this massification of AI, right? So like a massification of computing. Everybody has a phone now, can calculate pi to the millionth decimal. And now everybody has access to powerful AI models. And what they do with it, I don't know, get recipes for what to cook tonight. It's still a great thing, right? So we also have phones and we play games on it, but it's still a very powerful concept and paradigm that we witness. So now we have this, right? So everybody can use it. It's pretty amazing. Not the fact that we have a large language model. It's great innovation, transformers and so on. It's the fact that it's available to everybody, right? So, and I see also kind of, I will tell you the similarities with Docker Cloud Native later on. So, and this wasn't ages ago. It was 2022. We got ChatGPT, the first one. Not even a few months ago, we got these new models that actually are reasoning models, and who knows what next, right? So we always look at the new model, and there's also a lot of open source models and so on. So large language models are everywhere, and we have to deal with it, right? So, and we need to understand what to do with it, how can they help us, and what can we do to help the users and the consumers of LLMs. And from our perspective, the cloud native, Kubernetes people, I'm an old infrastructure guy, so I was wondering, what can I do to be part of it and to help the transition, to help people understand? And that's why we're here. So GenAI is not new. It's something that existed before. It's like a subset of what we call deep learning. Deep learning is this idea of extrapolating abstract concept, run them through a model, through a deep learning model, and get an output out of it. So, and this is basically how models work, right? So they take an input, they search over massively parallelized processes over many billions of tokens of information, and then they give you an output. So this is how you visualize our deep learning model works. There's been a rise, it's crazy, it's keep going, doesn't seem to go down anytime soon, and we all wonder what is going to be next. Is it going to be the AGI, the artificial generalized intelligence? And one thing that people, I really like to say it, so we are not talking about artificial intelligence, we're talking about alien intelligence. For the first time in the history of mankind, of this species, of this planet, really, we are building something that is not just the printing press, right? So the printing press was a great innovation, right? So we could finally print knowledge, distribute it, and it unlocked an amazing explosion of and progress of our species. now imagine books that can write themselves, right? So this is not even comparable to the printing press or the discovery of penicillin. This is a completely different ball game, right? So it's the rise of these entities, really aliens to us, as in they are not us, but they can reason over languages, which was a prerogative of our species. And they can go on and reproduce it. So we'll see where we're going. I don't want to scare anybody, but I am a bit scared myself of... Sorry, my daughter was calling. Yes. So LLMs are this, what they're good at. They take language. They make everything a language, and that's the genius part of a large language model. Before we had specialized models, like chemistry, I'm a chemist, there were models dedicated to analyze chemical structures. And then there were models that were specialized in analyzing vision and so on, and now we realize that everything is language. Everything can be decomposed into tokens that are resembling a language, then we can apply the technique to that. So we know this. So there are many commercial LLMs. They are open source. I like open source. I've been an open source person all my life. So there's a very important reason why language should be open source. Opens a whole set of questions, of course. But we are here to deal with it, and I want to show you quickly how cloud native can help you. One important thing we never realized, and we are here also to spin this conversation around the impact of what we do. Every time we train and we do inference, right? So every time we send a prompt, a question to a model, that's inference. That's something that generates, needs computing power and generates CO2. You can see here how much CO2 is consumed or emitted when models are trained. So we are not talking about small numbers. These are also massively trained over thousands and thousands of GPUs. So we need to think about very well, where are we going with this? It's not only CO2, it's also water. These machines, big machines, GPUs, they need cooling. Cooling needs water. Water is a scarce source. It's only going to be scarcer. Good, clean water is not something we should waste and feed computers with. We should think about the impact on the water ecosystem of what we do, especially when we massively adopt this kind of technology. So, and especially because it's important, especially because this water is in places that need more than the computer. So, for example, this massive data centers of Amazon in the middle of North Virginia. North Virginia is a populated place. It's not a desert. There are cities that need the water more than the data center. So we don't want to introduce this digital divide between people and computers. We don't want to make that choice. And for example, this prompt needs half a liter of water and makes 5 grams of CO2, right? So just to have a funny image to show in a presentation, right? So is it worth it? We need to ask this question. But let's move on to cloud native, which is, let's get less gloomy and talk about cloud native. What is cloud native, right? So I've been talking about is cloud native. It's a bit confusing. So there are definitions, but I want to show you how we got there, right? So there was a time, I was alive, right? So I was there. I was, in 1991, I was 15, and I remember the first Linux distribution uploaded on FTP, Java, 1995, and then fast forward 10 years, Amazon, the cloud, we were still doing pretty much virtual machines, even when Amazon came out. There was all EC2, maybe some database, but mostly was a convenient way to run virtual machines. So the revolution didn't really pick up pace. But after that, of course, with the introduction of, and Docker, introduced in 2013, didn't invent containers, but it made it popular. That's why I compare it to what OpenAI did. They didn't invent, per se, AI or LLMs, they make it popular. They give it to the people to use. Likewise, Docker took containers and gave it to developers to use. And that kind of accelerated the advent of cloud native. As a matter of fact, just a year after that, less than a year, Google posted Kubernetes on GitHub, and the CNCF was formed to manage the single project, the one project, Kubernetes, and then soon enough, many more projects joined the party, right? So, and now we are 208 projects, more or less, all part of this big family of cloud-native software. And what it is, I'll tell you in a moment, but is what we deal with when we want to deploy application in 2024 or 2025. And later on, we'll talk about also WebAssembly, how things are moving very fast towards a better future. So what is cloud native is this idea of having applications that are very elastic, so they can scale up, but very importantly, down. So applications don't scale only up, but when there is no more traffic or usage, they can scale down. So they're elastic, mostly microservices oriented, or at least they try to adopt the ideas of microservices. And most likely they are containerized, right? So just because containers unlock everything else, right? So putting them in a container or WebAssembly, as I will talk about towards the end of the talk if I have time, makes it better and enables everything else, enables cloud native. So it's more cost efficient, scales, reproducibility. So you get your application, you put all this, all the dependency in a container, bam. You don't have to worry about outdated libraries and so on. Stable, resilient, blah, blah. I mean, we do it, right? So that's why I'm not asking anymore, are you using Kubernetes, but how do you use it? Are you harnessing the full power of Kubernetes? So these are some of the graduated projects. So these are the production-ready projects, the good ones, the ones that went through so much scrutiny and due diligence. They are finally graduated, right? So the first one was Kubernetes, of course, but very recently we got Dapr and Linkerd and Istio and so on. So they all graduated projects. So you can pick one of these and make sure you are sure that there is a strong community behind, there is a commitment, it's used in production in many places, and you can be sure that you cannot go wrong. It's like buying IBM in a way. Why we are talking about it? Because most of the AI and machine learning workloads, and most people that use Kubernetes does it for many reasons, of course, but one of the the fastest rising reasons is to run AI machine learning workloads. This is from a report from Portworx, very recent, 2024. I can only expect this to rise, to go up, right? So because you got an AI machine learning workload, it makes sense to run it in Kubernetes, right? So that's not gonna tell you much about it, but there are some, so this is the traditional way of doing application, and this is how AI application looks like. It's completely different, so there are different phases. There's training, inference, serving of those models, and so on. I'll talk about it soon. I don't have a lot of time, so I'll quickly go through. But the main takeaway is that there's no more like I have some code and I compile it and now it's running. With AI, with machine learning applications, things are more fuzzy. So I'm running a model, then I'm gonna run experiment on those models. Is it still relevant? Is it giving me hallucination? Is it giving me the results I'm expecting from? And if not, how can I train it on different data sets? How can I compare this version of the model? So it's a bit more fuzzy. It requires a probably different approach, which is enabled by Cloud Native and Kubernetes. That's the whole point of the talk. So we have this experimentation going on. I need to serve those models so data scientists, users can use them, see them, compare them. And all this stuff, of course, I still need the classic pipelines, right? So I still need probably GitHub Actions, Azure DevOps pipelines, or something that enables a developer to to package those models. And most importantly, most of this stuff requires massive investment, massive infrastructure that I need to provide, and I need to provide fast to the model. I cannot work. It needs to be an elastic, scalable infrastructure underlying the whole thing. So Kubernetes is perfect because it runs everywhere, like literally. You can run it on the edge. You can run it on every single. Everywhere there is a Linux kernel or a Windows kernel or some kind of computing power, you can run Kubernetes. So that's it's been proven to work massively at massive scales. Famously, OpenAI does the training of the ChatGPT, the GPT models on Kubernetes clusters, and it helps you with the problems that comes with this job scheduling, right? Which is the fragility of batch jobs, as in, if you are running a training and one of the compute node goes down, you don't want to lose everything. You don't want to, you want to make sure that the calculation keeps going without interruption. So, what we got so far? So, there are two ways cloud native can help AI and vice versa, right? So, AI helps cloud native because now we have this amazing tool we can run our infrastructure through, right? So we can say, AI, please help me understanding, am I running my application right? Can I do something to troubleshoot it? Can I improve security? But also cloud native technologies like Kubernetes helps running AI workloads. So resource intensive, GPU scaling, there's all problems there. They are hard to do with classic infrastructure, classic orchestrator, or no orchestrator whatsoever. So you need the power of Kubernetes and cloud native to harness to mitigate this problem when you have to train large language models. So Kubernetes brings to the table resource allocation is platform agnostic. I don't want to repeat myself. The pros are single platform, so you have one platform to do everything, like from training, inference, serving. There are tools that can help you do everything in Kubernetes. It's scalable, can run on multiple locations, can span multiple clusters, and can do more, and can harness the power of GPUs because companies like NVIDIA, they were one of the first adopters of Kubernetes for their own workload. So, and out of all this, of course, CNCF is a big house. People start talking about topics, like we started talking about sustainability 2 years ago. About the same time, actually, within the CNCF, the working group AI was born, part of, because it's just a working group, and a tag is a technical advisory group, right? Technical advisory group, yes. So the working group has to live inside a tag, and they found the tag runtime, which is also the tag that takes care of the project related to container runtimes, including WASM and including containerd and CRIO and so on. So that's the home of the cloud native AI within the CNCF. And what does it do? It produces artifacts like white papers, guidance. There's a landscape also. This was released around this year. Cloud Native AI white paper goes through the old topics. I'm talking about this in this talk. Talks about this stuff. So what tool to choose, where to get the information out when you want to run large language models on Kubernetes, or in general, like AI machine learning workflows. So it kind of puts together all the tools, all the knowledge in one thing. And this is the CNAI landscape. Is a subset of the cloud native landscape that everybody hates or is scared of. It's actually a filter. You see, like you can filter by just focusing on the cloud native AI related projects, right? So, and some of these are owned by the working group, as in they are CNCF projects, so they are part of the Cloud Native Computing Foundation, so the trademark, the community is part of that. Some of them are completely separated, of course. They are some of them are commercial, like VLLM. VLLM is open source, Hugging Face, and so on. So some projects in the CNCF that I'm going to show you as well, if I have time, 16 minutes, so let's see if I can go there. Most important is Kubeflow, right? So Kubeflow is a Kubernetes native platform. It's a really a comprehensive platform. You see it includes like a bunch of tools like pipelines, a visual dashboard for pipelines, but also TensorFlow, Jupyter notebooks, and so on. Just a way to install all you need to run models, training, inference, serving in Kubernetes in one go, in one coherent way. But in fact, Kubeflow is also made of different components, including Knative and so on. K8s GPT, which I have time to show, it's a way to analyze a cluster with AI about problems and to troubleshoot a cluster with AI. It's not there, but this is also the future, right? So who knows what WebAssembly is? Well, then I have to come next year to give a talk about WebAssembly. WebAssembly is a target architecture to compile binaries, right? So as you compile Java code for x86 or for ARM chips, like the one in my Mac, then you, instead of that, you can compile for WebAssembly. It's like a meta format for binaries that then, once you compile for WebAssembly, they can run anywhere, from browsers to servers to embedded systems and so on. So WebAssembly is really becoming the best way to run LLMs or AI machine learning workloads. So get rid of all your Python code. I mean, why you want to run advanced machine learning with Python? And also Python is just, let's be honest, Python is just a wrapper around C, right? So we just use Python just to call C subroutines, but why, if we can just do everything in Rust and WebAssembly? And if I have some time, and I can move this. Okay. You can see this, right? Well, I'll do my best. So this is a WASM edge binary. WASM edge is runtime, so it doesn't matter what architecture you're running with WASM edge. You can run WASM binaries. And this one, which is this Llama API server WASM, it's a web server, right? So that will serve this model, Llama 3.2 1 billion instruct, which I already downloaded. So I'm doing my best because I have to look at the screen and I also have to, but it's good for my back. So what happens here is that finally is running and is serving my, all right. No. Okay, so this is not good. I didn't think about. Yes, so this is the interface of Ollama, right? So I'm serving a model that runs on my computer via WASM, so it's not architecture specific, and I really cannot see, but what is OpenConf? And this is running on my machine, a model, but is served through WASM Edge, which is the runtime tool that runs WebAssembly application. And then, if I can show you K8s GPT. So K8s GPT, I configured it with my OpenAI API key. So it is actually retrieving the Kubernetes manifest from the default namespace. If you can see, I have a pod in the default namespace, and it's not working, right? So it is not running. And maybe I can ask AI to tell me what's going on. You see, it's actually getting all the manifest, getting all the status of the pods, sending it to OpenAI, getting a response back, and it's telling me, well, there must be, see, I called the image engine X6, and it's even telling me, hey, I think this should be engine X with one X. So the next thing will be that I'm going to tell KDH-GPT to just fix it by itself. It doesn't do it yet, but maybe one day, maybe you can contribute to the project. Maybe you can auto-remediate things, right? So something goes wrong, talk to the AI overlord, and fix it for us. I hope I impress you, or not, but it's cool stuff. We didn't have this stuff like 3 years ago. So platform engineering, cloud native. So there was a lot of interest in platform engineering. Now I think we are actually looking at AI. Green software is becoming de facto a very important thing to discuss. We haven't talked about it, but I'll come next year to talk about all sorts of stuff. And last but not least, I'll be on my way to the meetup. So if I'm not special or anything. I just started organizing meetups 10 years ago, and that's where I am now. It's like a public speaking, part of the CNCF. And you can be too. Just join your local community. The Kubernetes Athens meetup is pretty cool. I think we will be on time. I'm not going to talk about Kubespaces, but I'll be very happy to talk about it personally. I'll be here tomorrow as well. And I'd like to leave you with Epictetus, one of my favorite hero, with a quote. And I would like to thank you. And we have 9 minutes for questions, if there are any.
Thank you, Alessandro. And I think it's important because, you know, for all the different cloud-native foundation projects, it's very difficult for someone to navigate. Yeah. There are very, very many. So I think it was a good introduction. Yeah.
Let me add one thing. If you want to join, it's nothing special. We have a Zoom call every week. That's it. You join the Zoom call. It's every Wednesday, 5 p.m. And that makes you part of the community. There's no form to fill. There is nothing. It's not a club. You show up. You are part of the community. That's it. You find what we are working on. Maybe you have time to fix some issues or write a piece of the white paper. That's it. That's all all we need. You don't need to code. You don't need to be special. Nobody's special. Everybody's doing their own part. That's what we do.
Yeah, that's great. That's great.
Yeah.
Do you have time to take some questions, or do you have to hurry? I don't want to keep you from the meetup or have the Uber waiting. So are we fine for a couple of questions?
Yeah.
Yes. Let's see. Okay. At least we have one.
Yes.
Is Kubernetes really used by small teams, or does it usually require a full DevOps team to operate it for a company?
It's a great question. It's also the reason why we are building this startup, Kubespaces, because we want to give Kubernetes to everybody, even who doesn't have the resources to run it at scale. It is actually useful for everyone. Like I run it in my closet. I have a bunch of servers. But yeah, it's actually useful for small and big shops. And the idea is like you are small today, you may grow later. So why not jumping on the right bandwagon soon enough, right? So yeah. So and if you need help, there's plenty of people to help you.
For me, just a question for me. The cost of AI is. I was yesterday reading an article which said, okay, in order for to prompt your questions in ChatGPT, it costs you like, I don't know, so plastic. Like, I don't know how many bottles of plastic in equivalence, I mean.
Yes.
Yeah. So
CO2, plastic, and so we have this idea of the three, so when you calculate your impact, you have to think of the 3 domains, right? So not only the power you're consuming in that moment, But where are all these computers that you are using coming from?
Yeah.
What were the production manufacturing processes? Where is the electricity we are using? Where is it coming from? So there's more than meets the eye when you, not the AI.
And everybody's not all. Now it's more people using AI than non-technical people are using now ChatGPT or whatever. So it's even more. Okay, the impact is even more, and no one realized that now. Everybody's like hungry. Okay, and the hype is big. Yeah.
We are working on a sustainability in AI white
yeah,
paper.
so the green software.
Yeah, so that's at least we're not going to fix the problem. Everybody is part of the problem, it's part of the solution. Yeah. But we want to surface the problem. Like, okay, by ignoring it, it's not going away.
And awareness, okay,
awareness,
to everyone.
Yeah, that's the most important.
Yeah, and I'm curious, did this initiative in Cloud Native Foundation start with the rise of AI, or did you consider about how to be more sustainable even before?
No, AI is just one part of it. Environmental sustainability looks at the whole landscape, right? So we want to know how to calculate, monitor, and possibly remediate waste of resources, including emissions and power. So for example, we have projects like Kepler and Kate and other stuff, and Kubernetes, what helps you understanding if you can switch off some workloads. Of course, the workload you don't need to run, they consume nothing. So that's the best. It's like the code you don't need to write. But if you do need to run workloads, can you move them around? Because there's a measure called SCI, the software carbon intensity, which is a global index of what that code you're running consumes. And it's also including running in Norway. It's cold, so the servers don't need that much heat, and so on and so forth, that much cooling. So you need to, it's not easy, and we're just getting started. We're only two years old, and we really don't have a lot of clues. So that's why we need the input from everybody.
Yeah, that's very interesting as well.
Yeah. Okay.
Thank you. Thank you very much.
Thank you very much.